Hello, my name is Derek Owen, and here is my final project presentation for CSCI 490 AIT, AI and Internet of Things. For my project, I did an AI-assisted plant health monitor. Here's just an example of the web app display, and here's an example of my setup. It uses a Raspberry Pi, the Pi camera module, taking pictures of the plant down here, and all of the sensors are connected via breadboard. So for the problem statement and motivation, houseplants often suffer from silent stress, such as light, temperature, and watering issues. So the task I set out to complete was to create an automated IoT Internet of Things AI-assisted plant health monitor using deep learning techniques and a Raspberry Pi. So the idea is to create a low-cost Raspberry Pi system that can track environmental conditions and uses a camera and an AI model to detect leaf stress from images. So for the approach and methods I used, the hardware setup was a Raspberry Pi 4 Model B with a Pi camera module 3. So here's the Pi connected here, and the camera is right here, taped down, taking pictures of the plant. So for data collection, the system takes readings every 5 minutes, logs them in just into CSV files with 7 days of history. And those, the current data, the current readings are displayed along with the 7 days of history are displayed on the dashboard, which is a Flask web app running on the Pi. It displays live indicators and graphs for light, temperature, and moisture, along with that 7 days of history. So for the actual training of the model, I used a very simple MobileNet v3 small model trained on the Plant Pathology 2021 dataset. And the hopes of training that model was that it would detect this leaf stress. Here's an example of the plant pathology dataset. Over here we have a healthy plant from the dataset, and here is an example of a leaf displaying stress. So the idea is to have this external inference server on the laptop using the trained model weights. So the pipeline here is that the Pi captures a photo, sends it to the server, and receives the predicted probability of stress, which it then displays on the web app. So the results of training, I trained the model just for 2 epochs and got plenty sufficient results here. As you can see from the confusion matrix, I only missed 48 of the over almost 2,000 photos from the data set. And here is just some demo pictures I took of plants I had in my room. Top left here, it predicts stress, and it very clearly obviously has a lot of stress there. This one too has some stress there, and it predicted stress with high confidence on both of them, pretty high confidence. This one, however, I don't really see too much stress, maybe around the edges, maybe down here, but it predicts stress, but with a much lower confidence score. So maybe that's good, maybe not so good, but this also may be due to the fact that the data set itself had a lot more stress images than it did healthy ones, so it was a little bit imbalanced. So maybe some class balancing could help the model there. Also, the dataset mainly features leaves like this, which are very basic green looking leaves. This plant here has much different types of leaves, so it got confused with this kind of plant, which I wanted to showcase here. It predicts stress here, but I don't really see any stress. And this leaf here clearly has a lot of stress, and it is about 50-50. It doesn't know. And here are just some pictures of my whole setup. So here we have the web app running on the laptop, but the laptop is also running the inference server in the background there. And here's the Raspberry Pi display from the HDMI to this monitor, and it is actually running the web app, which is just taking the stress inference from the server running on here, and the web app is displayed on a local server. And here's the Raspberry Pi connected to the camera, and the Pi connects to the breadboard here. You can see the different sensors. We have the light and temperature sensors here. This component here is just so that is just used to get the soil moisture sensor, which is plugged deep into the plant. It needed this extra component to work with the Raspberry Pi. I think it was designed for Arduino, so we needed this extra component to adapt it to the Pi. So we have the light and temperature sensors, and the moisture sensor is deep into the plant. And finally, for the limitations and future work, the current limitations are that the data set is very limited. It's not a very big data set, and it's only features very specific types of leaves. It's not very general. Another limitation is that the inference currently runs on the laptop. The reason it runs on the laptop is because I couldn't get it working on I couldn't get PyTorch working on the Raspberry Pi. There was just a lot of issues getting that downloaded on the Pi. And another limitation is that obviously I don't have the money to spend on a bunch of Raspberry Pis and cameras, so there's only one Pi and one camera. So future work would be to collect more data or get a better data set for better training, to get better model weights for inference, and more future work could be add the capability for multiple plants. Maybe you could do that with just one Pi and one camera, or maybe you would add more Pis, more cameras, one for each, or maybe one for 4 plants, if you can segment the photo into each one and run inference on each one individually. More future work could also be to improve the user interface on the web app. And that is all. Thank you. Okay, so here is the actual setup I have. Here's my plant, and the moisture sensor is tucked in there, plugged into the breadboard with the light and temperature sensors and the adapter for the moisture sensor, which plug into the Raspberry Pi and has the camera pointing down at the plant. And here is the web app running on my Raspberry Pi, and here's the actual dashboard. You can click update now. And it's updated. It displays the most recent photo, says whether it thinks the
Photo is displaying stress, talks about the temperature, the light, and the moisture, and displays the last 7 days of readings of the light, temperature, and moisture. And the inference server is running here on the laptop.